Right, friends, we are in 13.3 now. Compound inequalities. And so that's like a compound word or a compound sentence. So it's got two things coming together to make one. There's a few words, you with them, you may not, so we will definitely define them as we go along. So anyway, a compound inequality, you're going to have two inequalities. So you can have something like x greater than 7 or x less than or equal to -2. That's a compound inequality together. They form one inequality. So if you were going to graph this, you would have x greater than 7. So let's put 0 here. 7's going to be out here. Greater than, open dot, going to the right. Or x is less than or equal to -2. So we'll put -2 over here, solid dot, solid point, and we're going this way to the left for less than or equal to. So that's a compound inequality. Both inequalities are on the same number line. And so we draw them separately like that. All right. So let's talk about a word, the word union. I think of weddings, like Holy Union or the whatever. I'm thinking Princess Bride right now. But anyway, so the union is numbers that are in either of these sets. So you could say if this is, let's say, set A, I'll write down set, union would be set A or set B. So a number that falls in set A or set B. So let's look at, this is our set A and this is our set B. So what is a number that falls in either set A or set B? You could pick 10. 10 would be one. -4. 0 would not. 0 does not fall in either of them. So it has to fall in one or the other. So the union is abbreviated A union, it's like a U, B. And it is we'll call them numbers, I guess, for now, but they can be other things. So numbers that are either in set A or set B. So they can fall in either one. Okay, so let's look at a different compound inequality. Let's look at, let's do x greater than -1 and x less than 5. So if we graph this one, here's 0, and 5 will be up here, -1 is down here. So x is greater than -1, open, off this direction, and x is less than 5, so going this direction. So we have some overlap. So notice we're using the word and versus the word or. So we're looking at where do these two sets overlap? And they overlap between -1 and 5. We could even write it as -1 is less than x is less than 5. So you can convert this to look like this, and it means the same thing. This is called the intersection. It's the intersection. So if you have set A and set B, the intersection is A, and then it's an upside down U in this case, B. And those are numbers in both set A and set B. All right, so intersection has the crossover. I think of like an intersection in a car. The intersection is where the streets cross over. Oh, there's my illustration. Intersection, if you're driving on a road, it's where the two streets cross over, so it's where they overlap. If you're paving the streets, it's where the asphalt would overlap. The union is anything in one or the other. So it doesn't have to be in both. It can be in one or the other. It's a little bit more forgiving, I guess you'd say. This one is more precise. So we've got and goes with intersection, or goes with union, and here's our abbreviations. All right. Okay. So let's do, I should grab a new board. Let's do an example. We're going to draw the graph of x is greater than 5 and x is less than or equal to 8. So do we have a union or an intersection on this one? Look at your key word here. So it's going to be an intersection. And I'm going to put 0 down here. 5, 8. So x is greater than 5, open, going this way. And x is less than or equal to, so solid, 8. So that would be our graph. All right. And then we could also write our inequality as x, and then we've got greater than 5, but less than or equal to 8. That's another way of writing the same compound inequality. All right, so let's do this one. Let's sketch the graph of, 3x plus 7 less than negative 8. I know some of you are getting excited because you just saw some algebra show up. Or 5 minus 2x is less than or equal to negative 9. So again, pay attention to your word here. That means we have a union, okay? So let's start on this inequality over here. Subtracting 7, so I get 3x is less than negative 15, so x is less than negative 5. Over here I subtract 5, so negative 2x is less than or equal to negative 14. Divide by negative 2, so x is, don't forget to flip your sign, greater than or equal to 7. And we are going to graph this now. I've got 0 here, negative 5, and a 7. X is less than negative 5. Open, going to the left, it's a less than. X is greater than or equal to 7, so solid, going to the right. All right, let's do another one. We're going to sketch the graph of, here we go, this is going to be negative 6 less than 5x minus 2 less than 13. So very compound here. All right. Isolating x. We want x to be in the middle by itself. So we add 2, but we have to add 2 to everything to keep this balanced. So we have to add 2 to all parts. So negative 6 plus 2 is negative 4, less than 5x, less than, this will be 15. And then we're also going to divide everything by 5. So we've got negative 4/5 less than x less than 3. All right, so let's take a look at the way it's written. This would be a union. So let's graph it. Here's my 0. Here's my negative 4/5. Here's 3. X is going to be larger, greater than negative 4/5. So open dot, we're going this way. But x is going to be smaller than or less than 3, open circle. So there is my union right there in between the two. And then one other problem, we're going to work backwards. You're going to be given the graph and you need to come up with the inequality. So example, you're going to write the compound inequality. We're going to have this picture. This is what you're given. Negative 7, negative 3, here's your 0. and open circle, we're going to the left, and closed circle here, going to the right. So first of all, intersection or union, just by looking at it. This will be a union, there's no crossover. So let's first of all take this left side. X is less than but not equal to -7. And or. If we're doing a union, we use or. X is greater than or equal to, don't forget because it's solid, -3. And that's your compound inequality. Easy enough? Can we handle it? All right, one last one. I'm going to use some words instead of a picture. So if X is between -5 and 3, and then I'm going to use this fancy word inclusive, write the inequality. And draw its graph. All right. So X is between. Union or intersection, do you think? If it's between. Think about a picture. Is this a between picture? Not really. We were going to want the intersection. So X is going to be in between two things. It's going to be in between -5. So I'm going to put, since -5 is smaller, that's going on the left. 3 is going on the right. It's the larger integer. Inclusive. That means we're going to include -5 and 3. That tells me we're going to do a less than or equal to on this. We do not, it is not standard to do 3 greater than or equal to X greater than or equal to -5. That is not standard nomenclature for math. It's not written in order, right? We always read a number line from left to right, so -5 should naturally be on the left and 3 on the right because this is the smaller and negative, this is the larger positive. So please do not write them this way. Stick to the number line. And then we'll draw our graph. Here's my 0, -5, 3, solid, and we're in between. And there you go. I'll see you at Zoom.